Now we're going to move on to Warwick Allen. He's a researcher at Manaaki Whenua, and he's going to talk about integrated ecological impact assessment.
Thanks, Belinda. So I'm going to talk about our project, which was a collaboration between Manaaki Whenua and NIWA. We had three main project objectives. First one was to identify changes in the extent and condition of vegetation cover as a result of Cyclone Gabrielle. Second was to evaluate impacts on wetlands, naturally uncommon and threatened ecosystems and species. And then finally, NIWA led the part of the project on quantifying resilience of resident fish and macroinvertebrate communities and recolonisation of migratory fish species. Next slide. So this map on the left is sort of an overview of where we collected data from throughout the project. I won't go through every point in detail, obviously, but before I highlight a few examples, I just wanted to say a big thanks to all of our project partners, regional councils and other organisations, that without them this work would not have been possible, of course. They played a huge role in this project. So a few little bits of data that we collected. The first part was we did a sort of an aerial image assessment intersecting a damage layer that was produced by another group here at Manaaki Whenua of new bare ground. So this was eroded areas or sediment deposition, and intersecting that across different ecosystem types. Next, we visited forests and quantified wind damage in the Bay of Plenty. Next. NIWA collected eDNA and macroinvertebrate community samples. This is the blue dots in the Hawke's Bay and Gisborne region. We revisited wetlands that had been sampled before the cyclone. Those are the blue squares in the Hawke's Bay region. And I interviewed over 60 eco-sanctuaries around the North Island to get an idea of the impacts on conservation infrastructure and threatened species. So a few of the key findings on the next slide. Actually quite good news for our native ecosystems. So compared to pastoral ecosystems and exotic plantations, native vegetation experienced a lot less damage. So this figure on the right shows the new bare ground. That's the other Landcare Research map. And the key takeaway here is that for all these different ecosystem types, we see the percent of damage is less than 2% overall. And for ecosystems like indigenous forests, so that's your tall, mature podocarp forest, less than 1% of damage. So fairly good news, better than we expected anyway. Wetlands, we saw much the same. So this is showing wetland condition index. If we go back one. So this is a composite score of about 20 different variables, and wetland condition only declined by about 5% compared to pre-cyclone levels, and this was largely as a result of sediment input and damage to vegetation. Next. Freshwater fish species fared remarkably well, actually. So on the left of all of these slides, you can see pre-cyclone levels. So this is showing eDNA data from NIWA and Hawke's Bay Regional Council. And then autumn 2023, so immediately after the cyclone, we saw declines in some species, increases in other species. And then a year on from the cyclone, most of those species appeared to have reached pre-cyclone levels again, or if not better in some situations. So pretty good news for freshwater fish as well. Next. But what we did find was that it was uncommon ecosystems, threatened species, and conservation infrastructure that appeared to be most at risk. So this is ecosystems that have ecosystems or species that have a narrow distribution or that have low population sizes. They're obviously going to be much more at risk to these extreme weather events. And so one example here is from braided rivers in the Hawke's Bay, where banded dotterel numbers declined by up to about 50%. In some catchments and didn't decline in others. So there was quite a bit of variation in where these effects were occurred. And we saw consistent patterns between banded dotterels, black-fronted dotterels, pied stilt, South Island pied oystercatcher. So multiple species affected there. And then when we think about eco-sanctuaries, you saw a landslip taking out one of those predator-proof fences. Well, over 30% of eco-sanctuaries with predator-proof fences had breaches of those fences. So they hold our most precious taonga. So potentially big impacts there. Thankfully, no damage done. One final thing was that good baseline data is critically important. We need that pre-cyclone data to assess the impacts of the cyclone. Next. Long-term impacts remain uncertain, so we're yet to figure out whether or not these ecosystems are recovering. So that's a future question that remains unanswered. And finally, keep an eye out for all of this information and more that's going to come out in our report at the end of September. That'll be our main output. Thanks.